Hi, it's Rob. Welcome to this AWS hands-on tutorial where we'll work with AWS Step Functions. Step Functions is a low-code visual workflow service which developers use to build distributed applications, automate business and IT processes, and build data and machine learning pipelines using other AWS services. Step function workflows are broken into multiple steps containing flow logic, and they track the inputs and outputs between these steps. Step functions also manage workflow failures and allow for retries using try-catch constructs, as well as support parallel execution. As we can see here, some common use cases for step functions are automation of ETL jobs, data prep for machine learning, and microservices orchestration. In this video, we'll focus on this last use case. However, before we start building, let's discuss a few key step function concepts. First, a step function is based on a state machine and tasks. A state machine is a workflow, and workflows come in two types, standard and express. Standard workflows are ideal for long-running jobs up to 1 year. They're durable and have an auditable workflow. Express workflows are ideal for high-volume event processing workloads such as IoT data ingestion, streaming data processing and transformation, as well as mobile application backends, and they can run for up to 5 minutes. A task is a state in a workflow that represents a single unit of work that another AWS service performs. Each step in a workflow is a state, and all work in your state machine is done by tasks. A task performs work by using an activity or a Lambda function, or by passing parameters to the API actions of other AWS services. The task states used in workflows are choice, which is used for branching, wait, which is used to introduce a delay in processing, map, which processes each element in an input array in a state machine, parallel, which provides for parallel task execution, pass, which passes input to output, as well as succeed and fail. In AWS Step Functions, you define your workflows using the Amazon States language, which is a JSON-based structured language which is used to define your state machine and adheres to a specific state machine structure. We'll take a deeper dive into tasks and states as we build out our state machine in this video. So let's head over to the AWS console and get hands-on with AWS Step Functions. To get started, I'll click on State Machines in the menu, then Create State Machine. For authoring method, I'll choose Write Your Workflow in Code, and the type will be a standard workflow. Here we see a sample workflow definition written in Amazon States language, which starts with a comment, and then we see a start at property. And if we jump back over to the state machine structure documentation, we see start at is a required string indicating the name of a state object. Then back in the workflow definition, we see the states. First, we see the hello state, which matches the start at state. Its type is pass, its result is hello, and the next state is world. Then there's the world state definition, whose type is also pass, the result is world, and then the end state is true. On the right-hand side, we see a graph of the workflow definition. It starts with the hello state, then progresses to the world state, and finally ends. Clicking Next, I'll give the state machine a name, and for execution role, I'll let Step Functions create a new role. Then scroll down and create the state machine. And here we see our state machine was successfully created. Here we can jump back into the definition, as well as edit the state machine. I'll cancel out, and then start an execution. I'll give the execution a name, and leave the default input. Then start the execution. And since this is a very small state machine, we see it's already completed execution. The green color and the check mark indicates that the state was successful. And if I select it, I can see the details of the state. Here it succeeded and the type was pass. The input to the state was the default comment and the output was hello. And we can see the details for the events. And the same for world. Here the input is hello, the output is world, the type was pass, and the status succeeded. And scrolling down, we see the list of events. So this was a pretty simple demo using a sample Amazon States Language workflow definition. What I want to do now is to create a new state machine which will invoke a Lambda function. So I'll head back over to State Machines, create a state machine. Again, I'll write my workflow in code, and this will be a standard workflow. For the definition, I'll replace the default states language with a definition I've created. This is the Amazon States Language workflow definition for Demo 1. It starts at the begin state, which is defined here. The type is pass, and the result has a message of hello from AWS Step Function Demo 1. And the end property is set to true. So I'll copy this, head back over to the console, and paste it in. And here we see our graph. Now I'll click Next, give it a name, and again I'll let Step Functions create a new role. And I'll create the state machine. Now let's go ahead and start an execution to test it. Again, I'll give it a name. I won't pass any input, and I'll start the execution. And as expected, because this state machine is so small, it's already completed the execution. The input was blank. The output was the message hello from AWS Step Function Demo 1. The type was pass and the status succeeded. And if we scroll down, we see the events. Okay, now that this simple demo is working, let's incorporate a Lambda function. Jumping back into VS Code, here we see I have a simple Lambda handler written in Python. When it's executed, it'll print the event and then return a JSON object. So I'll copy this code, head over to the AWS Lambda console, and create a new function. I'll give it a name. The runtime will be Python 3.10, and then create. I'll replace the default code with my Lambda handler, then configure a test event, save the event, and test. And here we see a successful response. Now I'll go ahead and deploy the function, grab the ARN, and head back over to VS Code. On the left, we have our demo1 JSON file. As you recall, this had a type of pass and a result of hello from AWS Step Functions Demo 1. On the right is our new JSON. Once again, this has a start at the begin state. The begin state this time has a type of task. So instead of passing the result through to the end like we did in the first demo, this time we'll execute a task, which is a resource equal to the ARN of the Lambda function. Now I'll go ahead and save this, copy the code, then head back over to the step function. Here I'll edit the state machine, replace the definition, save, and start an execution. And this execution will actually fail. And if we look at the cause, it's because the step function role doesn't have permissions to perform the Lambda invoke function. So I'll copy the role name, Head over to IAM, search for the role, and add a permission to attach a policy. And for the demo, I'll give it Lambda full access and add the permission. Now, if we jump back over to the step function and run a new execution, we see our execution was successful. Here, again, we had no input, and the output is the status code of 200, and the body, hello from AWS Lambda, which was returned from the Lambda function. Now, inside Lambda, if we click on Monitor, we see our invocation, and if we click View CloudWatch Logs and go into the log stream, we see the result of the execution. Okay, so this looks pretty good since we're able to execute our Lambda function. Now what I want to do is add some branching logic to our workflow. So let's jump back over to VS Code and take a look at the Lambda function. Here I've made a couple modifications. First, I've imported random and then created a variable with status codes. Then in the return, where I'm setting the value of the status code, I'm randomly choosing a value from the status codes above. So let's copy this code, head over to Lambda, replace the existing code, and go ahead and deploy it. Now we see it ran a test and it returned a 500 response code. So let's test it again. This time we get a 403, and let's test it again, and here we have a 200. Now let's jump back over to VS Code and look at the demo3 JSON file. Here we could see in our states, in addition to a begin, we have a new check response state, a success, a fail, and a default. So as before, our start state is the begin. So if we jump into it, we'll see it's our task type, which points to the resource of our Lambda function. Then after the Lambda function executes and returns, the next state is the check response state. So opening up check response, we see this is a type of choice, and the choices have a variable which checks the status code in the response. If the string equals 200, then the next state will be success. If the status code equals a string of 403, the next state will be fail, and if it's neither 200 nor 403, then the default state will be executed. Looking at the success state, we see it's a type of pass, which has a result with a status of 200 and a message of success. The fail has a type of pass, a status of 200 and a message of fail, and the default is similar with a message of default. So let's go ahead and copy this code, jump back over to the step function console, and this time I'm going to create a new state machine. Again, we'll write the workflow in code. It'll be a standard workflow, and I'll paste in my workflow definition. And on the right, we see the graph. So again, it starts with the begin state, then goes to the check response state, and depending upon the status code returned from the Lambda function, it'll either execute the success, fail, or default states, and then move to end. So go ahead and click next. I'll give the state machine a name. This time I'll choose an existing role, and I'll use the demo1 role, which has permissions to execute Lambda, and then create the state machine. Now I'll start an execution. And that was pretty quick. So here we started with the begin state. It had no input, and the output was status code 200. So when we went to check response, the input here was status code 200, with the output of status code 200, and success state was called, which has an output of message success. Now let's go ahead and execute a new execution and see if we get a different response code from the Lambda function. Okay, and now we went to the default. So if we check the response, we'll see that the status code was a 500. And if we were to execute this again and got a status code 403, we would go into the failed state. And after a couple more executions, we see the status code 403 was returned. We executed the failed state, and the message is a fail. Okay, we're making progress here. Now, what I want to do is implement custom error handling with a catch block. So, jumping back into VS Code, let's look at the update I made to the Lambda function. Here, I've created a variable named status codes, which is randomly choosing a value from the status codes variable. And if the status code's equal to 500, I'm going to raise a new exception for an internal server error. If the status code's not 500, I'm going to return the response with the status code equal to the status code in the variable above. So what I've done is I've copied this code and jumped over to Lambda, deployed, and here we see a test response with the internal server error. And if I test it again, here we see a 200. Now jumping back over to VS Code and looking at demo4.json, we'll see in our begin state, after the task execution for the Lambda function, next we're going to the check response state as before. However, I've added a catch property. And looking at the catch, if the error equals an exception, then I want the next state to be the internal server error state. And looking at the internal server error, we see I'm setting a message of internal server error. The check response state still has a choice for 200 and 403 and has the same behavior as our prior demo. So let's copy this code, jump back over to the step function console. I'll create a new state machine, paste in the definition, and now we see our new graph. So we'll start with a begin. And if the Lambda function returns a 200 or 403, we'll go to check response like before and either go to the success or fail states. However, if an exception is thrown in the Lambda function, I'll go to the internal server error state and then end. So I'll go ahead and click next. I'll give it a name of demo 3, choose my existing role from demo 1, and create the state machine. Now let's go ahead and start an execution. Okay, and here we see we started, we went to begin. This returned a status code of 403, which is passed to check response. So we went to the fail state and set the message to fail in the output. Now let's go ahead and test again. This time we will return to 200, so we went to the success state. And let's test again. And after several more executions, we see the begin is an error with the error of exception. So we invoke the internal server error state, which set the message to internal server error. All right, now there's one more demo I want to do, and that's to add retry logic in our workflow. So looking at demo 5 here, in our begin state, we still have our task type and our resource of the Lambda function. On return of the Lambda function, the next state will be check response. And we have our catch for the exception, which goes to the internal server error state. However, I have a retry property. And this checks to see if the error equals task failed, and then with an interval of 1 second, max attempts of 2, and a back off rate of 2, it will retry executing the task again. So if the Lambda function executes and we get a successful status code, we'll go to the check response state. However, if the task fails, then we'll retry. So let's copy this code, jump back over to the step function console, create a new state machine, choose the role, and create. Now let's go ahead and start an execution. Here we see our begin state is executing. And if we check the response, we see we got a status code 200. So we went to the success task and set the message to success. And if we scroll down and look at the events, We see the Lambda function succeeded, as did our execution. Now, let's run another test. And here we see our begin execution finished. We got a status code of 403, so we checked the response and went to the fail state. And again, our Lambda function succeeded, as did our execution. Now, let's run another test. Here, a begin state is executing. It's in error. We see the exception was thrown, so we went to the internal server error state. But let's scroll down. And here we see our first Lambda execution failed. And then there was a retry, which failed again. And then on the final execution, the internal server error exception was thrown again. And then our execution succeeded, and we set the message to internal server error. So that concludes this demo on AWS Step Functions. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching.